Alright, so let's go through this try yourself 8, which is a 2016 A-level question. So non-uniform bar AB, right, makes an angle 60 degrees with the horizontal surface. So the whole thing is at equilibrium. So we are asked to use the POM to show that the magnitude of X is 8.8 Newton. So apparently, if you recall your equilibrium, you must know that the equilibrium, there's two conditions. First condition is resultant force is equal to 0. Second condition is CW equal to ACW. So we are actually using the second condition to solve for this question. Okay, since the whole thing is not moving, we know that clockwise moment is equal to anti-clockwise moment. No? So let's determine our let's locate our pivot first. So we must put our pivot at point A. So I put my pivot at point A, right? So apparently there's two forces acting on the rock AB. So the first force is our weight, 36 Newton, and the second force is the force X, right? So we are asked to calculate force X to be 8.8 Newton. Okay, so let's determine which one will actually cause the clockwise moment. So for clockwise moment, it's actually caused by the 36 Newton, meaning it's this up. So you can see it's actually a clockwise moment. Then the anti-clockwise moment is actually caused by force X. So this is your ACW. The next thing is actually to calculate our moment. So let's start off with our clockwise moment first. Okay, moment is F times D, or what we call F cross D. So F, so if you look at the cross product, it's actually FD sine theta. So it's FD sine theta. So F is the force. So in this particular case, right, is our weight. So this is our force. Okay, what about the D? The D is the distance from the force to the pivot. So in this particular case, it's actually your 0.45 meter. Okay, what about theta? The theta is the angle. Angle must be between something and something. So the something and something is called the force and the distance. So this is the angle that we are talking about. So but the question is, how do I actually determine the angle, the so-called the theta? So this is where you need to extend your arrow, right, or the line. So you extend the arrow, it's like that. So there's a force right here. I mean, there's a right angle triangle. So right angle triangle. So right angle triangle, so this is 60 degrees, right? So this is 60, this is 90. So of course with the angle, this will be 30 degrees. So that's how I know sine 30. So FD sine 30 will be the total clockwise moment. So if you calculate 36 times 0.45 times sine 30, right? So this will actually give you 8.1 Newton meter. Okay, now we determine our anti-clockwise moment in terms of X. Okay, so X is the force. So I want to calculate force. So this will be my X. Okay, what about the D? The D is from the force to the pivot, meaning is this part. So which is 1.2. Okay, what about the angle theta? The angle theta is the angle between the force and the distance, right? Or the D. Okay, how do I determine the angle theta? So okay, for this, right, you can see this is actually 60 degrees. So this 70, right? Then this will be 50. Meaning that this angle right here will be 130 degrees. So this sine, that's why I put sine 130. So if this, right, you calculate in terms of X, this will actually give you 0.919x. So you just calculate for X, right? Your X should be around 8.81 Newton, round off to 8.8 Newton. So this is how you show the working. So of course, I think I forget to add one more thing. I must put, before I write down CW equal to ACW, I must put let pivot to be at point A. So this so this one is something that we must show them also. Alright. Okay, so this will be 8.8 Newton for force X. Okay, let's move on to the second part, which is a qualitative question, explanation, right? Okay, so a force F actually acts on the bar at point A. So why a dark force is required to act on the bar at A to keep the bar to be in equilibrium? So same thing, there shouldn't be any resultant force. Okay, if you look at this picture right here, or this diagram right here, right? So apparently there's a weight downward 36 Newton, and of course we now know my force X is 8.8 Newton. So this 8.8 Newton. So just erase all this. Okay, so there's a force X of 8.8 Newton. So this is force X. Okay, so If you look at 36 Newton, 36 is vertically downward. And let's just say I resolve the 8.8 Newton to the horizontal and the vertical, right? Of course, obviously, for the vertical force right here, you cannot be 36 Newton because this so-called the diagonal force right here is only 8.8 Newton. Meaning that the vertical component of the 8.8 Newton must be much lesser than the 36 Newton. So of course, there's a resultant vertical force downward acting on the rod AP. Okay. Next will be the horizontal. If you look at this, if you look at the force X or the 8.8 Newton, right, there is a horizontal component force pointing towards the left hand side. So if there's no force acting on point A, right, there will be a resultant force acting on rod AB. There's a resultant downward vertical force and the resultant horizontal leftward force, right? So this is not allowed. In order, you want to be equilibrium, right? There shouldn't be any resultant force. Means that for the force at point A, you must have a vertical force in this direction, and of course, you must have a horizontal force in this direction. Because this horizontal force right here, right, is to counteract this force right here. And this vertical force right here is to help this vertical force, which is the vertical force of the force X, right, to counteract this 36 Newton weight. So meaning, let's just say, okay, I call this point 1, force 1, then force 2. This force 1 plus force 2 must be equal to 36 Newton. So the total upward force must be equal to the total downward force in order for the resultant force to be 0 in the vertical direction. Of course, there's one more force, which is the horizontal force, right? So the horizontal force is this. So let's just say I call it point 3. So force 3 and force 4 must be equal to each other. So this is 3 must be equal to force 4. So that's how we actually see. So of course, how do I explain? We just need to explain in this manner. 2 marks. So okay, first, downward weight of 36 Newton and the vertical component of force X is less than 36 Newton. So there is a vertical resultant force downward. Okay. So second point, horizontal component of force X is towards left hand side. So of course, point number 3, you must say, oh, there must be a force acting on point A, so that as to ensure there's no resultant force in the horizontal and vertical direction. Okay, with this, I will move on to part 2, which is to calculate the magnitude of force F, right? Okay, so how do we actually calculate the magnitude of force F? This is where we need to resolve the vector for the force X. Okay, I go back here. Of course, I need to erase it. Too messy already. Okay, so now I withdraw the force X in this direction. So this is 8.8 Newton as calculated. Okay, of course I can resolve to the horizontal component and the vertical component. I use green. Okay, so this is a horizontal and vertical component, right? Okay, let's deduce the horizontal component first. How do I actually deduce the horizontal component? This is where you look at this, right? This is 70 degrees, meaning that the angle right here must also be 70 degrees. Okay, so I draw here. So this is 8.8 Newton. Then this is the horizontal component. So this is 70 degrees. So I simply just use, because 8.8 will be the so-called hypotenuse. So the horizontal force right here will be the adjacent. So I must use cosine. So cosine 70 degrees is equal to j over 8.8. So I must use calculator for this. So adjacent, right, 8.8 times cosine 70. So this will actually give me a roughly 3.009, which is as good as saying 3 Newton. 3 Newton. So the horizontal leftward force is actually 3 Newton, meaning that this force must also be 3 Newton. Okay, now I want to determine the vertical component of the 8.8 Newton. So how do I actually determine? So I must use the sign, right? So because you look at this, right? So this is 8.8 Newton. Then of course I draw the thing. So I want the upward force or the vertical force, right? So this is 70 degree, and this will be the 90 degree. So I want the opposite. So sine 70 is equal to oppo over hypo. So let's determine what is the oppo. Okay, it's about 8.269 like that. So this is 8.26929. Okay, just write all the string of number. Newton. So this is the vertical force right here. So meaning that 8.82692 so and so forth, right? Plus this thing must give you 36 Newton as shown by this thing, right? Okay, let's write the working right here. So okay, the horizontal component of F, right, is equal to 3 Newton. What about the vertical component? Vertical component of F. So this is the F, then plus 8.269, right? 8.269295063 must be equal to the weight, 36 Newton. Okay, double check, is it 30? Yeah, 36 Newton. Okay, then I solve for the vertical component. No? So the vertical component, right? V component of F will be equal to 36 minus 8.269295063. So this will actually give you 27.73 something like that. 0.73070494 Newton. So that's the vertical component. Okay, now I'm not interested in the so-called vertical or the horizontal. I'm interested in this diagonal force, because apparently if I go back here, so there's a vertical component, there's a horizontal component, right? So if you combine them together, there should be a resultant force in this direction, in the so-called blue color direction. So I want to determine what is the magnitude of this blue color direction. I mean blue color force. So I simply just use Pythagoras theorem. A square plus B square equal to C square. So let's determine. Okay, let's do this together. So this is your. So if I draw, so this is your F that I want. So the horizontal 3 Newton, the vertical the vertical is 27.7. So this is your A, this is your B, and of course I want to find C. So I write here. So A square plus B square equal to C square. So C square I just put F square lah. So I just calculate. So 27.7 square plus 9 equal to 777. So F square is equal to 777.9919963. So what is my F? My F will be equal to square root. So square root 777.9919963. So this will actually give you around 27.89250789. So this will, you just need to round off to 3SF, 27.9 Newton. So the magnitude of the force at point A will be 27.9. So that is how we solve. Of course, you will see a bit tedious. So that's why it's a bit it's 3 marks as shown here. 27.9 Newton. Don't need to write Newton because it's already written for us. Okay, so with this, I will talk about the last part of the question. So on figure A, right, draw an arrow to show the approximate direction of our force F. So this one is quite simple. As long as you know they must pass through the common point, then you get the correct answer already. Okay, so I'll go back here, and of course I must erase. Okay, so okay, so for this, right, okay, I just extend my line a bit. I don't extend, I just draw the so-called line of action, right, dotted line. So this is the line of action of X. And then of course, what is the line of action of your weight is here. It's like, okay, wait a moment. Okay, so I draw the line of action of the weight using the purple thingy, right? this one is here. Okay, meaning that the common point is right here. So next thing, I just need to use a ruler, right? So I use a ruler, I use maybe a black color. Okay, so this is the common point, meaning that the force A must be like that. Then of course you use a long ruler, then you make sure that this black color arrow will pass through the same common point. So this will be the direction. So this one is 1 mark. So that is how you actually do these trials of 8. So hopefully this clear things up already.